All right, let's start. So, this class we'll do IMAT physics. So, IMAT physics, every year there's around three questions from the physics part of IMAT. So, you don't really have to worry much about physics. Just go through the classes I do and you will be good. But yeah, everywhere there's three questions from physics and like 4 5 questions from maths. So around 4 5 questions from maths and 3 questions from physics. And um, in total, there's like 8 7 8 questions from the math and physics section. So the math and physics section is combined, and you'll get around 7 8 questions from both math and physics. And the questions usually are uh, interconnected, meaning that physics will have a bit of math. You have to know how to do basic algebra, and for maths, you'll also have to use formulas from the physics class. Okay, so the first chapter for physics is measures. In this chapter, you'll know what units are, the different types of units. You'll also know how to derive base units, what are base units, everything about units and measurement is in this chapter. So let's get started. So, what is a physical quantity? What is a base quantity? First of all, a base quantity is a quantity that cannot be split any further into simple quantities. So a base quantity, right, is the building block of all quantities. And in physics, there's around 6 quantities, the base quantities that you need to memorize. It's these right here. So starting with length, you'll measure length around the world in meters. So all around the world, the base unit for measuring length is meters. And for time, it's going to be seconds. You can see that time has the base unit of seconds. That means this is the simplest of the quantities that you can measure time in. So all of the scientists around the world, they gathered around and they told everyone that, hey, we'll measure time in seconds. You'll find milliseconds, microseconds, minutes, hours, but the base quantity, the base unit that you measure time in is called seconds. For temperature, it's Kelvin, right? Kelvin has the symbol K. And you'll also find temperature in Celsius or Fahrenheit, but that's not the SI base unit. The base unit, the unit through which we do calculations or through which scientists they connect temperature around the world, it's Kelvin and not Celsius or Fahrenheit. Amount of substance is moles. You'll find this a lot in chemistry. Moles also has the formula uh, uh, mass over mr. This is where moles come in. And then electric current is measured in A or ampere. Ampere. And finally, mass is measured in kilograms, not grams, kilograms. Because grams is such a small measure that scientists said, hey, we'll measure everything in kilograms and not grams. So the 6 units you need to know: meter, seconds, Kelvin, mole, ampere, and kilograms. Right. So moving on, now let's get to derived units. So derived unit is a quantity formed due to the algebraic manipulation of the base unit. So when you take all of these units, right, and you move it around, you'll get a derived unit. I'll explain what I said right now. Uh, let's do an example of derived unit. Let's say we have speed, right? And speed has the formula of distance over time, right? And I know that distance is length. Distance is length, and time is time, and length has the unit m or meters. So I write, instead of distance, I write m, and instead of time, I will write seconds. So what I get is ms, m over s. Now I can simplify this further, because when I move a denominator to the numerator, the denominator gets a power of -1. Remember this. So when I go from, let's say I have A and B, when I move B to the numerator or simply moving it up, I will get this, where the B will get a power of -1. So I have M over S -1. I'll move this S upward, and what I get is speed is equal to ms -1. This is confusing, but let's do some more examples and it will get clear. So acceleration, right, is delta v over t, or change in time, change in speed or velocity over time. So change in velocity, right? Whenever you have a change, let's say there was a formula, PV equals to nRT, right? And this temperature was the final change, delta T, right? And this T would be measured in Kelvin. Similarly, when you have delta V, you will take delta V as V or simply speed or velocity. You'll not consider this two different units, because remember, delta V is V1 minus V2, but you don't do this. You'll simply take V. What do I mean by this? Well, when acceleration is delta V over T, right? Delta V, I know speed has the base unit of ms -1. So instead of delta V, I'll write ms -1. I won't write ms -1 minus ms -1. I'll not write this. I'll write it simply as ms -1 because that's the base unit of velocity. Divide this by time. Time is s, right? Seconds. And I can't leave it like this. For the exam, you have to move everything to its simplest form. So I move s upwards, and this seconds will get a power of -1. So I get ms -1 multiplied by s -1. This s -1 came from me moving this seconds upwards. So when two units are multiplying, remember this rule: when two units multiply, the powers add up. So for this two units, seconds and seconds are same and they're multiplying. So the power of similar base units, when two, I should write this as well, when two similar units multiply, the powers add up. So -1 will give you s -2. So I get ms -2 because these two powers add up. So here, acceleration ms -2, velocity ms -1. So I recommend you guys to memorize the basic ones, meaning speed, acceleration, force, pressure, work done, because you won't get enough time in the exam to do this part yourself. So it's better if you simply memorize all of these. So let's do a difficult one now. Let's do work, right? So what is work? Work done, right, is, I know, force into distance. And what is force? We break force further down because I know force is not a base unit. So force is mass into acceleration, right? Mass into acceleration. So do I have a base unit here? Yes, I have. Mass is a base unit. So instead of mass, I'll write kg. And is acceleration a base unit? No, it's not. Acceleration is a derived unit. Remember, there's only six base units in physics. The six base units, you need to memorize them. But all of these, right? Speed, acceleration, force, pressure, all of these are derived units. So acceleration is not a base unit, it's a derived unit. And the formula for acceleration was ms -2. I did it just right here. Acceleration is ms -2. So I get kg into ms -2, right? So this is the base unit for force, kg ms -2. And distance, is distance and base unit? Yes, it is, because distance is length. and length has the unit of meters. We have to memorize 9 of them. Not 9 of them. There is a lot more formulas that that's not written here, like energy. There's a lot of formulas, but what I'm saying is that memorize the basic ones: the speed, acceleration, force, pressure, work, the most common formulas that you'll find in physics. I wrote these because these were the most common chapters that came in the IMAT. So I wrote all of the formulas that were frequent in the IMAT. So memorize these formulas. Before I continue, right, I want to talk about the chapters that you'll find in IMAT. So I know there's only 3 questions every year in IMAT. And what I found, I did around 9 years of past paper, and I found that the most common chapters for the IMAT were kinetics. Kinetics, this is chapter number 2 in the IMAT, and it's about speed, distance. So stuff related to that is called kinetics. That's very frequent. And another frequent chapter I found is vectors and forces. So vectors were you would figure out the direction of forces and the measure of forces. So this is, I think it's chapter 4. I'm not sure though. This is vectors and forces are very frequent. And this chapter right here, measurements, is also very frequent. So these 3 chapters, right, measures are also very frequent. So kinetics, vectors, forces, measures, these 3 chapters, as well as chapter number, I think it's pressure is also in chapter number 5. Pressure is also very frequent. And these 2 chapters, right, these 2 chapters, measures and pressure, will be in other subjects as well. For example, measures, you'll find this chapter in maths. You'll find it in biology as well. So maths and biology, you'll find measures in that subjects as well. So it's better if you understand this topic really well. And pressure, you'll find this in chemistry. I did pressure last week where I told you about this formula, PV is equals to nRT. This pressure, you have to memorize all of that, will also come in this part. So PV equals nRT, gas, ideal gas, you learned this in chapter, pressure chapter as well. So really understand these 3-4 topics and focus on the questions on these topics. Okay, so let's get back to the chapter. So yeah, I was doing work done. So work done has the formula force into distance. I know force is mass into acceleration. Mass is a base unit, so I write kg. Acceleration is not a base unit, it's a derived unit. So the questions they can ask you for this chapter is, what's a derived unit? What's a base unit? They'll give you different types of units. For example, they'll give you length, acceleration, charge, and they'll tell you, hey, what's a base unit and what's a derived unit? So you have to answer that. So acceleration is ms negative 2. And this is the base unit for force, kg ms negative 2. Now distance, as I said, is a base unit. So it will have meters as the unit. Now I see 2 similar units. I have 2 meters, right? So what is the power of these 2 meters? Whenever something doesn't have a power, I simply say that it's +1. The power of the units that doesn't have any power is +1. So +1 and +1, they add up and become +2. So for work done, right, for work done, the final base unit I get is kg, and these 2 m's, they combine together to make m2 and s negative 2. This is the base unit for work done, kg m2 s negative 2. Memorize this because you'll find work done in a lot of chapters. So work done, I said it's kg m2 s negative 2, right? And there's another rule that you need to memorize. It's that all energies will have the same unit of work done. What do I mean? Well, all energies be it kinetic energy, potential energy, elastic energy, stuff like that. All energies basically will have this unit, kgm2 s negative 2, because work done, right, is also energy. So work done and all energies will have the same base unit. I think I've written kinetic energy right here. No, I don't. So let's do kinetic energy now. Let's do kinetic energy and I'll prove it to you that it's the same. So kinetic energy I know is half times mv square. So what now another rule that you need to know is that constants are ignored when dealing with units. So what is a constant? A constant is anything besides a unit. This right here, a half is considered a constant. What else can be a constant? Pi, because pi has a fixed value. It's a constant of 3.14. So all of this, half or pi or any number, basically, when you have a units question, you'll ignore the constants. So kinetic energy is half into mass into velocity squared. So I will ignore this constant because I want to find the base unit of kinetic energy. So kinetic energy for now is mv square. This is not the formula, but I'm dealing with units, so I'll ignore the constant. Now kinetic energy, I know mass is kg, right? And velocity is ms negative 1. I solved it somewhere here, I think. Yeah, ms negative 1. This is the unit for velocity. So ms negative 1, but I square this because I have a square. So when some unit gets a square, you will multiply that unit. For example, negative 1 multiplied by 2, I get negative 2, right? So when I simplify this, kinetic energy would be kg. This m will multiply by 2 and I get m2. So kg m2 and s negative 1 multiply by 2 will give me s negative 2. And here you go, kg m2 s negative 2. And where is work done? Work done is right here, kg m2 s negative 2. Similarly, I could solve for potential energy, elastic energy, all of that, but I'll get the same formula. So remember, there are that all energies will have the same unit as work done. This is one rule of units. The second rule was that you will ignore constants when dealing with units. So constants are ignored, right? So I think everything is clear for now, right? You understood everything, or is there any questions till now? All right, I'm assuming there isn't. So I want to do one last example before moving on. It's charge. So charge, right? Or Q. This is the symbol for charge. And the formula for charge is current into time, right? And I know current a base unit? I've seen a lot of times they ask you current, and you'll think that current is not a base unit because current is a base unit. Electric current is a base unit, and the unit is ampere. So instead of current, I write A, and time is second, so I write S. So I get charge equals AS. Current, remember, it's a base unit and not a derived unit. It has the unit of ampere, right? So that was pretty much physical units. That's everything for units. And let's move on to prefixes now. Prefixes, you'll find it in biology, in chemistry, in maths, as well as physics. Not really in chemistry, but biology, maths, physics, you'll find prefixes. What are prefixes? Well, you know, meters, millisecond, microsecond, millimeters, decimeters, all that. Centimeters, centimeter is very popular. So this right here, this centi is called a prefix. Whereas this meter is called a base unit or a SI base unit. So when you add something beside a base unit, it's called a prefix. So there are, I think there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's around 10 prefixes you need to know. Just memorize this table. It will help you a lot. And I'll explain how you'll solve the questions. So tera, capital T, is 10 raised to power 12. This is the biggest prefix that you'll find. Terabyte, right, is very big. So tera is the biggest prefix. Gigabyte comes after terabyte. So gigabyte is 10 raised to power negative 9. GB is big, but TB, right? TB in storage is much bigger. So tera is 10 raised to power 12. Giga is 10 raised to power 9. Similarly, mega or MB, you'll find this in your phones. MB is 10 raised to power 6. Kilo is 10 raised to power 3. Deci, 10 raised to power negative 1. Centi is 10 raised to power negative 2, and so on. So what you need to know is that the smallest prefix is pico. It's 10 raised to power negative 12. And then the biggest prefix is 10 raised to power 12. And all of that in between, you have to memorize them. So when you have a prefix, right, and you want to remove that prefix, what you'll do is you'll multiply the value with the value of the prefix. So for example, I want to convert terabyte into simple bytes. What will I do? I know tera is 10 raised to power 12. So I multiply TB by 10 raised to power 12. And I get B times 10 raised to power 12. And this is how I remove prefixes. So let's do an example. 1 byte has 8 bits. How many bits are in 20 terabyte? So I know 1 byte, right? 1 byte has 8 bits. 8 bits. And I have 20 terabytes. So I have 20 terabyte, but I won't write it terabyte. I'll replace T with the value of tera, which is 10 raised to power 12. So I multiply the value of 20 by the value of tera, which is 10 raised to power 12. I get X bits. I want to find the number of bits, and using this, I can simply multiply and find the number of bits. Now, another rule of prefixes is that when you want to add a prefix, you will divide. And when you want to remove a prefix, you will simply multiply. So for example, I want to convert meters to centimeters, meters to centimeters. I know centi is 10 raised to power negative 2. This has a value of 10 raised to power negative 2. So I multiply m times 10 raised to power negative 2. And this will give me, I'll divide by 10 raised to power negative 2. Because I'm adding a prefix, I'm adding centimeters, so I'll divide by 10 raised to power negative 2. Similarly, if I wanted to convert centimeters to meters, I'll multiply by 10 raised to power negative 2. So multiply by 10 raised to power negative 2, multiply by 10 raised to power negative 2, and this will give me meters. Let's do one last example and then we'll move on. Let's say I want to convert kilometer, let's say 2 kilometers into, let's say centimeters. I want to convert 2 kilometers into centimeters, 2 centimeters. How will I do that? First step, I can't simply go directly from kilometers to centimeters. I have to remove this prefix. How will I do that? Well, I want to remove the prefix, right? So remember, removing prefix, I multiply. So 2 kilometer multiply by 10 raised to power 3, because that's the value of kilo, 10 raised to power 3. So 2 times 10 raised to power 3 is 10 raised to power 3 is 2000 meters. Now I've converted it to meters. I've removed kilo, I get 2000 meters. Now I can simply convert 2000 meter into centimeters. Ignore this 2. I want to convert 2000 meter into centimeter. How will I do that? Well, I know I want to add a prefix now. I want to add a prefix. So I will divide. by the value of centi, which is 10 raised to power negative 2. So 2000 divided by 10 raised to power negative 2. And I get this as the value. This value is in centimeters now. So 2 kilometers is around this much in centimeters. I think it's 200,000 centimeters. Yeah. So this is how you will convert one prefix into another. You will first remove the prefix, and then after that you will add that prefix, right? So this was prefixes, and I think that's the end. Now for physics and maths, what I will tell you guys to do is to do a lot of questions. So in this class, I'll do 2 questions for physics. This is from 2011, I think. Let's give you guys 2 minutes to solve it. I'll give you around 2-3 minutes. It's a difficult question. Remember, for physics and maths question, you have to take your time. So I would always do the physics and maths questions at the end, because these are only 3-4 questions for physics and for maths. So I spend take my time and solve the questions that I can. Take your time, solve it, and tell the right answer. So people are saying B. Let's see if it's B or not. Someone said E. I don't know. I didn't do the question myself. I'll do it right now in the class. So which physical quantity can be measured in joules per meter? It's energy for joules. Yes, energy is measured in joules. Now, what is joules? Joules is energy, right? The joules is basically energy. So what's the unit for energy? I told you guys earlier, memorize it. It's kg m2 s negative 2. I can derive it again if you want, but it will take time. So let's not do that. Simply memorize energy unit. Energy is kg m2 s negative 2, right? And meters is m, right? People are saying E as the answer. So kg m2 into s negative 2 into meters, joules per meter. It's joules per meter. That means, wait. Let's rewind. Joules is energy, right? Energy is force into distance, Newton meter. And I get kg m2 s negative 2 from here, right? This is Newton is force. Force is kg ms negative 2. You have to memorize this as well. Multiply this by meters, and you get kg m2 s negative 2 as the unit for energy. Now, they're saying that it's joules per meter, right? So joules divided by meter. Per means you divide. So what can I do? Now, this is positive 1. When I move it up, it becomes m negative 1. So when m negative 1 and m2 add up, I get m. So kg m s negative 2, right? Because I can move this m up. This will become negative 1, and m negative 1, m2 would give me m. 2 minus 1 gives me 1. So kgms negative 2. Right. So kgms negative 2 is the unit for which quantity? For force. kgms negative 2 is the unit for force. So therefore, E is the answer. So someone was saying B. A lot of people were saying B. Let's see why B is wrong. B is momentum. Momentum is mass into velocity, right? Momentum is mass into velocity. Mass is kg. Velocity is ms negative 1. So I get kg ms negative 1. But this is kg ms negative 1 is not joules per meter. Kg ms joules per meter is actually kg ms negative 2. So this is the reason B is wrong. And yeah, so E is the answer. Some people were also saying D as the answer. Remember, I told you earlier, work is kg m2 s negative 2. So this is wrong. They're not asking for joules. They're asking for joules per meter. Per means that you divide the value by meter. So work is kg m2 s negative 2, but joules per meter is kg ms negative 2. All right. So this was one question. I had another question in mind. Let's do this question. Take your time again. This question involves a little bit of math. So if you can't do it, no worries. I'll try to do it myself. I'll give you like 3 minutes to solve this one. Take your time, okay? This is maths question. This is a maths and physics question. So take your time, do it yourself. Don't rush the question. I'm out on that already. People are saying B. Someone said E as well because of nanometer. Okay, so E is the option, right? So there is some physics, maths to this question as well. I won't do the maths part. I'll use the calculator for now, but you have to know how to manipulate the decimals. I won't explain that, but I'll explain the physics bit of this question. People are saying C. Okay, so let's do this question. 3 spherical particles have the following diameters: 1650 picometer, I have nanometer, and I have micrometer. Picometer, remember, is 10 raised to power negative 12. Nanometer is 10 raised to power negative 9. And micrometer is 10 raised to power negative 6. Okay, so what is the order of diameter? Smallest first. What is the smallest value first and the biggest the last? Please say the answer. Is it E? I don't know the answer. I didn't do the question. I'll do it myself right now. Let's do E first. And some people were saying C as well. Let's convert all of these to 1 unit. All right. So let's convert all of this to meters. So 1650 in meters, 1650 picometer would be it would be 1.65 times 10 raised to power negative 9 meters, right? Nanometers is 1.5 times 10 raised to power negative 9. 1.5 times 10 raised to power negative 9 meters. Nanometer in meter is this much, picometer in meter is this much, and similarly, micrometer in meter is 0.0036 multiplied by 10 raised to power negative 6 would give me this much. So I'll do it on my calculator. Give me a minute. It's 3.6 times 10 raised to power negative 9 meters. Again, you have to memorize, you have to know how to convert this into this. So picometer, I multiply by 10 raised to power negative 12, and I get this values. You have to know how to do the maths part of it. I won't explain the math part, but I'll explain how you do it. So change to 10 power negative 10 units. Yes, what you're saying. So picometer is this much in meters, nanometer is this much, and micrometer is this much. Which is the smallest value? This one, right? The nanometer. Nanometer is the smallest, and the biggest one is micrometer, which is this one, because all of them have the same prefix. All of them have the same prefix, so I can use the original value, these values right here. So 3.6 micrometer is the biggest, and nanometer is the smallest. So nanometer is the smallest, and the biggest one is micrometer. So yeah, E is the right answer. Scientific notations are non-zero. Yeah, so E is the right answer. Some people were saying C. Picometer is, I understand that you guys might be thinking that I have pico, it's the smallest prefix, so this will be the answer because the first one is the smallest, and micrometer is the biggest prefix in this, so you'd think that this is the answer, but you have to look at the value as well. Picometer is 1.65, whereas nanometer is 1.5. So obviously nanometer is smaller than picometer in this case. Usually the prefix without any values. So when I don't have any values here, the prefix would be the smallest. In this case, the picometer would be the smallest, not the nanometer. But here I have value. So I have some value right here. I have some value right here. In this case, my nanometer is more smaller compared to my picometer. The points. Okay, so you understand this question, right? Okay, so do I have any other question? No, I don't. That was today's class. Yeah, so in the next class, I'll do the very important chapter called kinetics. So see you on Sunday. Bye.